everyone, today we are taking notes on classifying polynomials. By the end of this lesson, hopefully you'll be able to classify polynomial expressions by degree and number of terms. Polynomial is a fancy word for strings of terms, and you've worked with a ton of them in your life. They just get a little bit more complicated in Algebra 1. But polynomial itself literally stands for many terms. Poly meaning many. That's an M. So if I look at this example on the left, technically we have 4 terms strung together. 5xy to the second is its first term, negative 3x is a term, 7y cubed is a term, and negative 6. All exponents included are positive whole numbers, and the terms are separated by addition. When you see subtraction, you got to remember subtraction is just plus and negative. Hence why I said that second term was negative 3x and not 3x. The minus is really a negative sign. Okay? If we look at examples of not polynomials, anytime we have a negative exponent, it is not going to be a polynomial. Because if you remember from last year, a negative exponent means that that term should actually be in the opposite position. So that should be in the denominator. Correspondingly, if your term is in the denominator, it would have a negative exponent on it if it was written a different way, so we can't have those as polynomials. The other thing you can't have is the variable in any type of boundary. So the square root of a variable doesn't work. The absolute value of a variable doesn't work. None of those will be polynomials. You just have to have a plain old simple positive whole number exponent. So if you have an exponent with a fraction, again, not a polynomial. So we're looking at classifying in 2 ways. The first way we're going to classify polynomials is by their name. If they contain 3 terms or less when simplified, we can actually apply a name. Once they're above 3 terms, we just call them polynomials for many terms. The first name, if we only have 1 term, a monomial. Mono standing for 1. So a monomial is a polynomial with 1 term. All right, the examples given, 3a squared, single term, because anytime you create them through multiplication, whether they have letters and numbers or multiple letters and exponents, single terms are created through multiplication. So even if they get as complicated as negative 7x to the 4th, y to the 5th, that's a single term. All plain old numbers are single terms. All plain letters are single terms. Once I start adding and subtracting these terms, then I have polynomials, and if I just have 2 terms, I have what's called a binomial. Bi standing for 2. So a minus 6 is 2 terms, a and negative 6. This ugly guy is still just 2 terms. The 3x squared y to the 3rd is all one big product, so that's 1 term. The positive 4x y to the 7th is one big product, so that's a single term. So that's just 2 terms. 9w is a term, 4z squared is a term, 2 terms. Trinomial, when we start stringing 3 terms together, anything beyond this doesn't have a special name. So you can see we have 3 separate terms in each of these examples. X to the 5th, 9x, negative 4x cubed, a, b, and c, all separate letters. If it was a plus a plus a and they were like, and you could simplify them, you have to simplify first before you classify. All right, the second way we can classify a polynomial is by degree. First, we look at the terms by themselves. So the degree of a monomial. To find the degree of a monomial, a single term, you simply add the exponents. So the degree of a monomial, you add the exponents on all letters. And we're going to say variables because variables is the fancy word for letters. So 7a to the 5th is a 5th degree monomial. Here we have 2 exponents, a 3 and a 4. So again, in a single term, we add them. This is a 7th degree monomial. Here we only have 1 letter. All letters have an understood 1 exponent, so this is a 1st degree monomial. If we only have a number, whether it's positive or negative, that is your 0 degree. Because if I put a letter on it, it would need to have a 0 power to be equal to 1 and not really be there. Once we start stringing these monomials together, as a group, they will still only have 1 degree. You have to find the highest degree of individual monomials, and that is the degree of your polynomial. So the degree of a polynomial is the highest degree of each monomial. So here, this first example, I have 3 terms. So that makes it a trinomial. The highest degree, I have to find each of the terms' degree and classify it. So this first guy is a second degree term. The second guy is a first degree term, because it's be the first. This last -7 is 0 degree term. So the second degree is the highest term. This is a second degree, and it's a trinomial. And that's messy. No. Meal. When I'm working this one, I have 2 terms, 2x cubed and -9y cubed. That makes it a binomial. This first term has a 3rd degree. The second term is a 5th degree, so the 5th degree wins. This guy is a 5th degree binomial. Here, again, we have 2 terms. Doesn't matter how many letters are involved. 4w cubed y to the 5th is all one term, all one big product. 3 plus 5 gives me an 8th degree term. 2 plus 4 on this one gives me a 6th degree term. So the 8th wins. This is an 8th degree, still 2 terms, binomial. All right, I want you to pause now and do the 3 practice problems on the bottom of your page. When you finish them, unpause the video and check your work with the key and finish the video. Okay, hopefully you paused the video and took your time to work those out. This first guy has 2 terms, which makes it a binomial. By degree, this first term is a 3rd degree, second one is a 5th degree. This is a 5th degree binomial. Here we have a single term, that makes it a monomial. We add the exponents, this is a 7th degree monomial. Here we have 3 terms. None of them are like, so we can't simplify them. So it's going to stay a trinomial. This is a 5th degree term, 3rd degree term, and 4th degree term. The 5th degree term is the highest. So this is a 5th degree trinomial. Now we're going to practice this again on Monday and add in simplifying these polynomials and work with them for the next week or 2. Don't forget, the second part of your homework is to get that syllabus that you got in class on Monday signed. Read through it, make sure you understand anything. Come in with questions on Monday if you have them. You need to read through it and sign in the first part here. That's where the students sign. And then make sure your parents have read through it and signed it on the bottom. You can remember also try and bring in your class fee or tell your parents to go online, and you can do all your class fees at the same time. It's $5 for Algebra 1 this year. All right. Bring those 2 things. Those are the 2 homework assignments. You'll be graded on Monday. Have a great weekend.